Choose your strategy. Systems of linear equations can be solved using any of the three methods we've previously discussed: graphing, substitution, or elimination. Before solving a system, an analysis of the equations should be done to determine the best strategy to utilize. Technically, you can use any of these strategies, but a system will often lend itself nicer to one of these methods. Graphing, it's really nice if both equations are set up in slope-intercept form, and if you have a nice integer y-intercept and slope, or a rational slope, but most importantly the y-intercept, and then your solution happens to be one of the places where the graph units are, where you can see an integer ordered pair. Substitution is nice if one of your equations is solved for a variable, if x or y is by itself in one of the equation, and elimination is best when your equations are written in that standard form, when your variables are both on the same side of the equal sign. So let's take a look at an example of a problem that requires us to write and solve a system to answer the question. We have, although altogether 300 tickets were sold for a basketball game. An adult ticket cost $3 and a student ticket cost $1. Ticket sales for the event were $494. How many adult tickets were sold and how many student tickets were sold? So first we have to define our variables. What are our unknowns? What are we solving for? So the unknown is A, we can use that variable for the number of adult tickets, and S we can use for the number of student tickets. That's what we're trying to figure out, how many of each were sold. Step number 2 is then to set up a system. Use the given information to write two equations relating S and A. So first we're told that altogether 300 tickets were sold. So that's where the equation A plus S equals 300 comes from. It's that number of tickets sold. And then we're told that the money collected was $494. So if we take into consideration that an adult ticket costs $3 and a student ticket costs $1, we can make the equation that 3 times A, $3 times the amount of adult tickets sold, plus S, $1 for every student ticket that's sold, would equal $494, the total amount collected, that much money. Now that we have the system, we need to solve the system to find the values of A and S to answer how many adult and student tickets were sold. We're going to solve the system using elimination. This is because the equations we've written are written in standard form. The variables are on the same side of the equal sign. They're all lined up, and that variable S has a common coefficient. They both have a coefficient of 1. So we can subtract the equations from each other, that second equation from the first equation, to solve for A. We're eliminating S, and we're getting that 1A minus 3A is negative 2A, and 300 minus 494 is negative 194. And then if we divide both sides by negative 2, we get that A equals 97. Once we've solved for A, we can solve for S by substituting in that value of A back into either equation. So we can use A plus S equals 300. So it'll be 97 plus S equals 300. And if we subtract 97 from both sides, we get that S equals 203. So if A equals 97 and S equals 203, that's what we were able to solve for. That's the solution to the system. Well, we can interpret then that means there were 97 adult tickets and 203 student tickets sold. And we can check our answers and see that those values of A and S create true statements in the original equations as well, meaning that those are our answers, and we've checked that that is the correct interpretation of the problem. And we were able to use elimination to solve a system that we wrote to answer the question.